Section 1.9 is about exponential notation and order of operations. And to introduce this topic, let's think about how we defined multiplication. Multiplication, we said, for example, if you write 4 plus 4 plus 4 plus 4 plus 4 plus 4, so we add 4 5 times to itself, so instead we said 5 times 4, or 20. So in other words, repeated addition we can express in terms of multiplication. So this exponential notation now is about the idea, what do we have repeated multiplication? So when we look at that, for example, the product of 3 times 3 times 3 times 3, this is what leads to exponential notation. They occur frequently enough in mathematics and physics and chemistry that we found a convenient way to create a shortcut, a notation called exponential notation. For example, we have 3 times 3 times 3 times 3, 4 factors, and we write that as 3 to the 4th power, where the number 3 is the base, and the number that's a little bit higher is called the exponent. If you look in Microsoft Word, there is a way to write exponents this way also. It's an icon there, you have to look for it, but it's there. And so we're going to learn in part A how to write exponential notation for certain products that have repeated multiplication, and then how to evaluate these exponential notations and how to simplify expressions using the rules for order of operations, and then removing parentheses within parentheses. So there are 4 objectives for section 1.9. Now, how do we read exponential notation? Well, here's a notation, 3 with a 4 a little bit higher. It's called 3 to the 4th power, or the other way around, the 4th power of 3. Either way, 3 to the 4th power or the 4th power of 3. These expressions, the word descriptions are equivalent, of course. Or here we can say 5 cubed, or the cube of 5, or 5 to the 3rd power, or the 3rd power of 5. So in other words, there are many different ways of expressing exponential notation. 5 cubed, 5 to the cube of 5, 5 to the 3rd power of 5. Or, for example, here we have 7 with a raised number 2. It's read as 7 squared, or the square of 7, or 7 to the 2nd power, or the 2nd power of 7. So you have 2, 3, 4, up to, 4, well, there are other ways to do it also, but about 3, 4 different ways of expressing exponential notation in the English language in the word description. So here's some simple exercises. Write an exponential notation. 5 times 5 times 5 times 5 times 5. So how many times is 5 multiplied by itself? Well, it's 4 times. And so the base, of course, is 5. That's the number here, 5. It's repeated 4 times, so that's 5 to the 4th power. Similarly, in number 2, the base again is 5. And here we have repeated multiplication of 5, 1, 2, 3, 4, 5, 6 times, the 5 to the 6th power. Okay, and the next one, number 3, 10 times 10, so the base is 10. And there are 2 factors of 10, so it's 10 to the 2nd power. Here, number 4, again the base is 10. And here the multiplication by 10 is 1, 2, 3, 4 times, so it's 10 to the 4th power. The next learning objective deals with evaluating exponential notation. So we want to be a little bit careful for example, 10 to the third power does not mean 10 times 3. It means 10 times 10 times 10 times 10. So evaluate 10 to the fourth. So we multiply 10 4 times by itself. 10 times 10 times 10 times 10. And so it'd be equal to 10,000. Similarly, 10 to the second power, that means 10 times 10, and that's equal to 100. 8 to the third power, that means 8 times 8 times 8, or 64 times 8. Which is equal to 512. And 2 to the fifth power means 2 times 2 times 2 times 2 times 2. So that's equal to 4 times 2 is 8, times 2 is 16, times 2 is 32. So here the answer is 32. So evaluating exponential expressions is fairly simple. You can also do it with your calculator. So I'd like to show you a little bit about your phone calculator. So this is an iPhone calculator, and that's in standard portrait mode. It turns out then when you have it in landscape mode, it turns into a scientific calculator. You can do a lot with that. And so, for example, we have this key here, the X to the Y button, this one here. And so for the problem of 3 to the fifth power, what we do is we type in the number 3, and then we touch the X to the Y button, X to the Y power, and then we put in the 5 for the exponent. And so now that's our answer. 3 to the fifth power is equal to 243. So you may want to try that on your own phone, and I think Android phones work about the same way, but certainly this is correct for an iPhone. Or let's do the same thing with 5 to the sixth power. So we clear what we have, and so we input the base first. The base is 5. That appears up here, and then we touch the X to the Y button, and now we input the exponent 6, and then we touch the equals button. So it's 15,625. $15,625. Again, I would encourage you to try that on your own phone, on your own calculator. There are different calculators. Some have a different way of doing it, so you need to figure that one out. But this is how it works for most phone calculators. Similarly, 12 to the fourth power, that's 20,736. Again, using your calculator, and 2 to the 11th power is 2048. So just use your calculator and see if you can get the same answers. Maybe you have to work on this a little bit, but it's really pretty convenient to have that available to you. The next topic is about simplifying expressions. So suppose we have to evaluate the following expression, 3 plus 4 times 8. So the question comes up, do we add the 3 to the 4 and then multiply by 8, which would be 3 plus 4 times 8, which would be 7 times 8, or 56? Or do we multiply 4 times 8 first? We have 3 times 3 plus 4 times 8, and 4 times 8 is 32, which would be equal to 35. Obviously, only one answer is correct. They couldn't both be correct because they're different numbers. So what we have here is a hierarchy of operations. There's addition and multiplication. And as it turns out, multiplication takes the precedence over addition. And so there's a set of rules called the rules for order of operations. In other words, in which order we perform certain operations. So next we're going to talk about the rules for order of operations. And so before we get into that, let's talk about why we have an order of operations. And that is, number one, to have predictable outcomes. Order of operations is something you encounter every day. For example, traffic lights. They impose a certain order of operations, which car goes first, or which, how traffic moves. And as long as people stick to the rules, everything is okay. The problem happens when people don't stick to the rules and you have accidents. Or if you follow a recipe, that is certainly order of operations, or even how you open a door. You have to do certain things to open a door. If you do it the wrong way, you cannot open the door. If you pull it first before pushing down the handle, the door won't open. So they're pretty simple things, some are more complicated. But so in math, we have rules of operations. We have an order of operations, so we all get the same answer. Predictable results. So here's the order, or hierarchy. Do all calculations within parentheses, brackets like this, or braces, before operations outside. Now some expressions don't have parentheses of any kind, so you don't need to worry about that in some cases. Then we evaluate all exponential expressions, if there are any. And do all multiplications and divisions in order from left to right. That's an important step also, from left to right, as you will see. And then do all additions and subtractions in order from left to right. So these rules are really, really critical, and you need to memorize them. Otherwise, you don't get it right. So that would be important. So these are the rules for order of operations. So let's simplify this expression here. So we have number 93 minus 40 times 3. So since we have multiplication and subtraction, we know what we have to do first. We have to do the multiplication. So that means we have 93 minus 14 times 3 is 52. And 93 minus 52, 42 rather, is equal to 51. Similarly, here we have 104 divided by 4 plus 4. 104 divided by 4 is equal to 26. So 26, 104 divided by 4 is 26 plus 4, and that's equal to 30. So for number 11, we have 25 times 26 minus 56 plus 10. So we do the operation parentheses first. So we have 25 times 26. And 56 plus 10 is 66, so minus 66. So that means we have 650. 25 times 26 is 650. Minus 66 is equal to 584. That's the answer for number 11. And number 12 is very similar. we have 75 divided by 5, but we do the operation in parentheses first. So we have 75 divided by 5 plus 83 minus 14, that's 69. And 75 divided by 5 is equal to 15. Plus 69 is equal to 84. As you look at these exercises and how I solved them, I would encourage you very strongly to do that on your own. In other words, take a piece of paper and a pencil and work out these problems yourself and make sure you come up with the same answer. Okay? For number 13, we are supposed to evaluate these two expressions, which are basically the same, but they are grouped differently. So if you look at the first part here, 64 divided by, now we're supposed to do the expression in parentheses first, so 32 divided by 2 would be 16, and 64 divided by 16 is equal to 4. So that's for this part here. So 64 is rather 4. Now if we do the second part here, where we first divide 64 by 32, well, 64 divided by 32 is equal to 2. Well, let me write out 64 divided by 32 divided by 2 is equal to 2. 64 divided by 32 is 2. Divided by 2 is equal to 1. So in one case the answer is 1, or 4 rather, and the other case is equal to 1. So therefore, grouping makes a difference. What number 13 shows is that division is not associative, because depending on how you group the numbers, you get different results. But let's look at number 14, where we have 28 plus 13 plus 11. So here we add 28 plus 13, which is equal to 41. So, well, let me write 28 plus 13 plus 11. So we have equal to 41 plus 11, which is equal to 52. But, so here the answer is 52. When we look at the second part, 28 plus 13 plus 11, then we have 28 plus 24, and 28 plus 24 is equal to 52. So in both cases the answer is 52. Now we knew that all along because we know that addition is associative. We had that before in the previous section. In the guided solution number 15, we are supposed to simplify the expression 9 times 4 minus 20 plus 4 divided by 8 minus 6 minus 2. So 9 times 4, and then we do the expression in parentheses. So 20 plus 4 is 24. And here the expression in parentheses is 6 minus 2, that's equal to 4. And now we do multiplication, and 9 times 4 is 36. Minus 24 divided by 8 minus 4. And so we have 36, and minus 24 divided by 8 is minus 3. And 36 minus 3 is 33. And 33 minus 4 is 29. So then the final answer is 29. To do number 16 correctly, we evaluate the expression in parentheses first. So that's 5 times 5 times 5 plus 26 times 71 minus, in parentheses, we have 25 times 3, which is 75, plus 16 is 91. So that's the expression in parentheses. And now 5 times 5 times 5, that is 125. And 26 times 71 is 1,846. Minus 91. And 125 plus 1,846 is equal to 1,971 minus 91, which is equal to 1,880. So this is the answer to number 16, 1,880. For number 17, we don't have any parentheses here, and so we have an exponential expression, even though it's not expressed that way, but we look at the simplest multiplication. So going from left to right, we evaluate 30 divided by 5. So 30 divided by 5 is 6 times 2, and 10 times 20 is 200, and 8 times 8 is 64, minus 23. So it's equal to 12. 6 times 2 is 12, and 200 plus 64 is 264, minus 23, equals 12 plus 264 is 276, minus 23 is equal to 253. So that's the answer for number 17, 253. We simplify number 18 by evaluating the expression in parentheses first. So that gives us 95 minus 2 times 2 times 2 times 5 divided by, and 20 minus 4 is 20. So that's equal to 95 minus 2 times 2 is 4, times 2 is 8, times 5 is 40, divided by 20, and 40 divided by 20, 95 minus 40 divided by 20 is 2, and 95 minus 2 is equal to 93. This is the answer to number 18, 93. We simplify number 19 by evaluating the expression in parentheses first. So we have 5 to the third plus 26 times 71 minus 25 times 3 is 75, and 75 plus 16 is 91. So now we evaluate the exponential expression. So there would be 125. And 26 times 71 is 1,846 minus 91 equals 1,971. That's 125 plus 1,846 minus 91. That's equal to 1,880. And if that result looks familiar, it was it's the same as actually as number 16 when you go back and look at that. The only difference is in this case we have a 5 to the third exponential expression, whereas in number 16 it was written as 5 times 5 times 5 as a multiplication problem. But that's the only difference, really. So the answer for number 19 is 1,880. To simplify number 20, we do the expression in parentheses first. So 1 plus 3 is 4. So we get 4 to the third plus 10 times 20 plus 8 to the second power minus 23. The next step is evaluating the exponential expressions, and 4 to the third means 4 times 4 is 16 times 4 is 64 plus 10 times 20. And now with the next exponential expression, 8 squared, or 8 to the second power, is 64, 8 times 8, minus 23. Now we do the multiplication part. We have 64 plus 200 plus 64 minus 23 equals, so it's 264 plus 64 is 328. Minus 23, and that's equal to 305. Which is the answer for number 20. And for number 21, we evaluate the expression in parentheses first. So this gives us 81 minus 3 to the second power times 2 divided by, and 12 minus 9 is 3. So now we have 81 minus 3 squared, the exponential expression would be 9 times 2 divided by 3 equals 81 minus, do multiplication, left to right, 9 times 2 is 18, divided by 3 equals 81, and 18 divided by 3 is 6, so minus 6, and 81 minus 6 is equal to 75, which is the answer for number 21. And for number 22, we evaluate the exponential expressions first, and then we do the division. So 2 to the third is 2 times 2 times 2, which is 8. And 2 to the 8th power is 256, divided by 2 to the 9th power, which is 512. And 8 times 256 is equal to 2,048. Divided by 512, that is equal to 4. So that is the answer to number 22. So I have a little bit of a suggestion for you, and that is, if these operations are a little bit intimidating to you, I would really recommend you review and do additional exercises in the textbook, pages 75, 76, and 77, until you have a real good feeling about how to do the order of operations and evaluating exponential expressions, etc. This is just something you need to learn to do efficiently. Okay, so that you have confidence in your ability to solve these types of problems. Practice is the key. Practice, practice, practice. And again, that's why you have lots of little exercises on the pages I mentioned in the textbook, pages 75, 76, and 77. The next topic is about averages, and you're probably familiar with that topic in a way because we talk about the average, let's say, height of students of a group, or the average age of a group of people, and average incomes and average cost of housing and so on. So a lot of averages that you're familiar with, at least by, in the real world. So in order to find the average of a set of numbers, for example, the cost of houses, we use addition and then division. For example, the average of these numbers, 2, 3, 6, and 9, is found as follows. We add up, to come up with the average, we add the numbers 2 plus 3 plus 6 plus 9. These are the addends, and they add up to 20. And we divide them by the number of addends we have. So we have 4 addends, so we divide the 20 by 4, and that gives us an average of 5. So that's how we compute an average. So the fraction bar acts as a grouping symbol. So in other words, 2 plus 3 plus 6 plus 9 divided by 4 is equivalent to 2 plus 3 plus 6 plus 9 parentheses divided by 4. It means the same thing, the fraction bar. It's a grouping symbol which can take the place of parentheses. So thus we are using the order of operations when we compute an average. So here's the definition. The average of a set of numbers is the sum of the numbers divided by the number of addends. So here we had 4 addends, 2, 3, and 6, and 9. 1, 2, 3, 4. So that goes in the denominator. And so then we divide 20 by 4, and that gives us the average. So, for example, if we look at the average number of career hits, that's the example here. So here we have the career hits for 5 Hall of Fame baseball players. So in other words, we add up all the hits. So we have 2,876 plus 2,930 plus 3,110 plus 3,255 plus 3,419. And so we divide that by the number of addends. So we have 1, 2, 3, 4, 5. So when we add up the numbers in the numerator, the 5 addends, we get 15,590 divided by 5, and that's equal to 3,118 hits. So in this case, the unit of measure is hits. So in other words, we don't just have a number, 3,118. Remember, in word problems, we probably need an explanation what the number stands for. So in this case, the number stands for the number of hits, the average number of career hits of all 5. So next we'll be looking at removing parentheses within parentheses. And so when we have a situation where parentheses occur within parentheses, we can make them different shapes, such as brackets, braces, and so on. All of these have exactly the same meaning. So when parentheses occur within parentheses, commutation in the innermost ones are to be done first, so that we start on the inside. So, for example, when we look at number 24, so we start on the inside first, and so in other words, we have 9 times 5 plus 6 divided by 14 minus, and 5 plus 3 is 8, That means we now removed the parentheses with rounded parentheses, which is equal to 9 times 5 plus, inside the braces, we now have 6 divided by, and 14 minus 8 is 6, which is equal to 9 times 5 plus 6 divided by 6 is 1, which is equal to 9 times 5 is 45, plus 1, so the answer is 46. So when you look at the original expression and then the final answer is 46, you can say, well, we've really simplified that quite a bit. This looks very complicated, but in the end, it's a very simple answer. In the guided solution number 25, we evaluate the expressions in parentheses first. So there would be 18 minus 2 plus 7. 2 plus 7 is 9, divided by 3, minus 31, parentheses, minus 31 minus 10 times 2. So we evaluate 10 times 2, which is 20. And then here we have 18 and 9 divided by 3 is 3 with a minus sign, so minus 3. And then 18 minus 3, that would be 15. And 31 minus 20 is 11. And 15 minus 11 is equal to 4. So the final answer is 4. And again, I'd recommend you grab a piece of paper and do it on your own without looking at the solution, and see if you can come up with the same answer. That'll be a pretty good test whether you really understood these principles that we've talked about here. So this concludes section 1.9, and it's also concluding chapter 1.